Hi students, welcome to physics class. Today we are going to discuss about rectangular components of a vector in a plane. Rectangular components. Rectangular components of a vector in a plane. Once again, I am repeating the concept. Rectangular components of a vector in a plane. Now take x-axis, take y-axis, origin O, consider a point P here on x-axis, consider a point Q on y-axis. Now draw a parallel to x-axis, at the same time here draw a parallel to y-axis. These two will be intersect at a point. Now draw, that is nothing but a resultant R. Consider along x-axis the unit vector is I. Along y-axis the unit vector is j cap. Here I cap. Now here P is a point, Q is a point. Here this is resultant R. Now at the same time we took here an x-axis and a y-axis. Take a vector. This is A. Vector A. This vector A resolve into two rectangular components. This is origin O. One is along x-axis as AX vector, along y-axis AY vector. Here AX is equal to AX vector is equal to AX I vector I cap or magnitude of AX I cap. Similarly, AY vector is equal to AY j cap or AY magnitude into j cap. These two are very important. Please remember. Then AX is equal to AX I cap, that is equal to magnitude of AX into I cap. Similarly, AY is equal to AY j cap, that is equal to magnitude of AY into j cap. Now go for discussion. When a vector is stipulated splitted when a vector is splitted into two component, when a vector is splitted into two components vectors when a vector is splitted into two component vectors at a right angle at right angles to each other. Right angle to each other. The component vectors are called rectangular components of a vector. Rectangular components of a vector. Once again, I am repeating this point. When a vector is splitted into two component vectors at a right angle to each other, the component vectors are called rectangular components of a vector. Now consider a vector. Consider a vector A represented by OR has to be resolved into two rectangular components rectangular components rectangular component vectors along the direction of x-axis and y-axis. From O, draw from O, draw two axes. OX and OY at right angles to each other. At right angles to each other. Once again, I am repeating this point. Consider a vector A represented by OR has to be resolved into two rectangular component vectors along the direction of x-axis and y-axis. From O, draw two axes OX and OY at right angle to each other. From point R, drop RP and RQ perpendicular to OX and OY. Once again, from point R, drop RP and RQ perpendicular to OX and OY. Now, from point R, drop RP and RQ perpendicular to OX and OY. Now, OP vector is equal to AX vector, that is equal to magnitude of AX into I cap, and OQ vector is equal to AY vector, that is equal to magnitude of AY into J unit vector, that is equal to AX I cap. Here AY J cap. Now AXI and AYJ are the that means AXI cap and AYJ cap are the are the rectangular components rectangular components rectangular components of a vector. Once again, ax vector and ay vector are the rectangular components of vector A. Hence PR is equal and parallel to OQ vector. Therefore, once again, hence PR is equal and parallel to OQ vector. Therefore, PR is equal to OQ is equal to AY vector, that is equal to AY into J unit vector. Here QR is equal and parallel to OP. Hence, therefore, QR is equal to OP is equal to AX vector, that is equal to AX I cap. Once again, here QR is equal and parallel to OP vector. Therefore, QR is equal to OP, that is equal to AX vector, that is equal to AX into I unit cap. From the triangle law of vector addition, OR is equal to OP plus PR, and A vector is equal to AX vector plus AY vector. Therefore, A vector is equal to AX I plus AY J. The reason is AX vector is equal to magnitude of Ax into I cap. Ay vector is equal to magnitude of Ay into j cap. Consider, this is very important, consider this is equation number 1. What is the equation number 1? A vector is equal to Axi plus Ayj. Equation number 1. From right angle triangle, right angle, from right angle triangle, from right angle triangle, O R P cos theta is equal to OP whole by OR. Therefore, OP is equal to OR cos theta. That means Ax is equal to A cos theta. Consider this is equation number 2. That means what we understood? We understood Ax is equal to A cos theta, Ay is equal to A sin theta. What we understood? Ax is equal to A cos theta, Ay is equal to A sin theta. Therefore, Ax is equal to A cos theta. Equation number 2. Therefore, cos theta is equal to Ax whole by A. Consider this is also equation number 2. From right angle, from right angle triangle, from right angle triangle, O R P sin theta is equal to PR whole by OR. Therefore, PR is equal to OR sin theta. Once again, sin theta is equal to PR by OR. PR is equal to OR sin theta. What is PR? PR is equal to AY. Therefore, AY is equal to A sin theta. Consider this is equation number 3. Therefore, sin theta is equal to AY by A. Consider this is equation number 3. But OR whole square is equal to OP whole square plus PR whole square. Therefore, A square is equal to AX square plus AY square. A is equal to root of a x square plus a y square. Consider this is equation number 4. Therefore, tan theta is equal to PR whole by OP, that is equal to A y by AX. Consider this is equation number 5. Once again, but OR square is equal to OP whole square plus PR whole square. A square is equal to AX square plus AY square. A is equal to root of AX square plus AY square. Equation number 4. Therefore, tan theta is equal to PR by OP, that is equal to AY by AX. Equation number 5. See here two important diagrams. Take x-axis, take y-axis. It is vector A. It is a vector A. Consider it is angle theta. Now it is AX vector. This one is AY vector. Here this AX vector is equal to AXI, and also this AY vector is equal to AYJ cap, that is equal to magnitude of AX into I cap. Here magnitude of AY into J cap, and also AX vector we will get A cos theta. Similarly, AY vector is equal to A sin theta. These are the important points. These are the important points we will get derived from this diagram. Now see another diagram. Take x-axis, take y-axis, take vector A. Now it is theta. Here AX is equal to mod A cos theta. Here AX vector is equal to AX I cap. Here AY vector is equal to AY J cap. Now here AY is equal to mod A sin theta. Here AX is equal to mod A cos theta. This is another diagram. So today we discuss rectangular components of a vector in a plane. So these are the important diagrams and derivations. I hope you understood vector components. Thank you very much for watching this video. Thank you. Thank you.